Hello, I'm Mrs. Jordan, and I'm here to present Chapter 9 3/4 with my friends here from Ravenclaw and Hufflepuff. All right, they will be just off screen down here at the bottom. But here we go, Chapter 9 3/4. Chapter 9, Day 1, Question 1. We're solving for x, because this is algebra and that's what we do. In the past, you'll remember that we had x to the 1/3 power, and we used the reciprocal power to cancel that out. We got rid of squares with square roots, we got rid of square roots with squares. Now we have x to the 3/4 power, so we're again going to be using the reciprocal power. So instead of 3/4, we'll use 4/3. Parentheses very strongly recommended. Sometimes those parentheses are going to be absolutely required, and that's going to be if the inside here is negative. Now, from Chapter 1, when you have an x raised to an exponent raised to another exponent, we're going to multiply those. That will give us 12/12, which is 1. So we get that that is x to the first power, which is x. That's how we're going to solve for x. From Chapter 7, you'll remember that this means that we're going to divide it into 3 equal pieces. 125 divided into 3 equal pieces is 5 times 5 times 5. We want 4 of those 3 pieces, so we need another 5. That's 25 times 25, which is 625. Bam, done. Wow, what a quick question. That's because there's going to be 2 parts to this question. You'll have to get them both correct to get full credit. Now, over here, this one is harder. Why? Negative exponents. People do not necessarily like negative exponents. It's all based on Chapter 1. So this is raised to the negative 4/3 power. So the reciprocal of negative 4/3 would be negative 3/4. And very much needing these parentheses here because the negative 3/4 has to apply to the entire side here. Now, we might want to show a little bit more work here to make sure everyone makes it through. This negative exponent reciprocals this part, so I get 16 to the positive 3/4. That makes it look so much nicer. Now, we divide 16 into 4 equal pieces, 2, 2, 2, and 2, and we want 3 of those 4 pieces, which means if we multiply those together, we will get 8. Ta-da! Now, over here, this x is going to be to a fractional exponent, or this side here is going to be 125 to a fractional exponent. And I used to have students look at these to figure out that 125 to the 4/3 is equal to 625 and say, hey, you're going to break this up into 3 5s, and how many do you need to make this? You need 4 5s, so that's how you're going to figure out the fraction. Before we do this, I want you to remember something. Do you remember that 2x equals 3? If I were to solve this, I would divide both sides by 2, and I would get x equals 3/2. The side away from the x over the side closest to the x. This is how we've been solving algebra equations since pre-algebra days. Now, I'm going to show you how to do this one. We're going to take 125 and break it up into 5 times 5 times 5, which we already know from this previous problem. And 625 is 5 times 5 times 5 times 5. Now, when you're solving for x, you're going to look at the side away from the x over the side closest to the x. There are 1, 2, 3, 4 5s on this side, and there's only 1, 2, 3 on the side closest to the x. And you count them, the side away from the x over the side closest to the x, and you're done. Here, do you see how this is upside down? We're going to have a negative exponent, but we're going to look at, this gives us a hint. 3 to the what power? Well, this breaks up into many 3's, in fact 4 3's, but because it was reciprocaled, x is going to be 4/1, because this is only 1 3 on this side. You're going to have 4/1, and because this was reciprocaled, it will be a negative 4/1, and you can do negative 4 divided by 1 and get negative 4, which is our answer. Yay! Now, some of you might be wondering, how much can I not do and still get full credit? This is all very wonderful. I think you could probably get away without doing this. And you might be able to get away without doing this. I do want to see these guys, but you could probably get away without doing this. And this is just showing us where this all came from. So I do want to see some sort of work on all of these. So this would be the work I'm looking for here on these, and this would be the work that I'm looking for on there. So work and answer, work and answer, work and answer, work and answer. That is the minimum that you can do. Chapter 9, Day 1, Question 2. We're going to rewrite equations using logarithms. Now, what is a logarithm? A logarithm is something that's new this chapter. And the thing is that in 121, your college math class, you're going to be learning how to graph those. If you want, you can already start graphing them now so that you can get a concept of what exactly a logarithm is. And the thing is that we're going to have e to the, e is a number, it is a constant. If you remember pi, 3.14-ish, it is an irrational number, meaning a non-terminating, non-repeating decimal from back in chapter 1. E is another example of an irrational number. It's about 2.7-ish. So, the opposite of e to the is to use natural logarithms, which is ln. Now, why is a natural logarithm ln? We believe it is from French, so it says logarithm naturel. And if you look, ln only goes in the front. If you put it afterwards, it's going to be wrong. So this is the natural log of e raised to the x. And what's going to happen is that these are inverses of each other, meaning opposites. Kind of like multiplication and division. They cancel each other out. Adding and subtracting, they cancel each other out. E to the and ln cancel each other out, leaving us with x. And then all you do is you write this on this side. Now, you might even write parentheses here because natural log is a function acting upon the number 5. That's all you have to do to rewrite it. So, desperately need to see this work and then rewrite it with the answer. Now, natural log is the opposite of e to the, so the opposite of 16 to the is going to be a log with a matching base of 16. From chapter 1, 16 is a base, 1/2 is the exponent. This is a log with a base of 16. When the bases match, they will be able to cancel out. So this, we log base 16 on both sides. Parentheses, a very good idea, because remember, these have to go in front. They're a function acting upon what's after it. This is a function acting upon what's after it. The 16 and the log base 16, all this will cancel out, leaving me with 1/2 equals log base 16 of 4. Now you might wonder, hey, how much can I not show and still get full credit? At this level of math, you could not show these parentheses, and these parentheses, and these parentheses. You don't necessarily have to show that these cancel out, as long as they do cancel out. Same thing here, you don't have to show that these cancel out, as long as they do cancel out. You don't necessarily have to have these parentheses here, as long as you have your logarithms in the front. That would be all the steps that you could get rid of. By the way, this here represents the basis for an entire chapter in 121. Chapter 9, Day 1, Question 3. Now, we just did a question where the opposite of e to the was ln. So now, the opposite of ln is e to the. Now, it's going to be e raised to the ln x equals e raised to the 5. And again, These will cancel out, giving me x equals e raised to the 5th power. Now, in previous sections, I told you that if the exponent is ever larger and lower than the base, I would have to mark it wrong. There is still that thing to worry about. Now, the opposite of 16 to the was log base 16. I have a log base 16. My opposite is going to be 16 raised to the log base 16 x equals 16 raised to the 4. Hey, I need to see this. And then, blah, this will all cancel out and give me x equals 16 to the 4. Now, notice, it just says to rewrite it in exponential form. That is an exponent, this is exponential form. That is an exponent, this is exponential form. There are some students who want to multiply 16 times 16 times 16 times 16 and figure out what that is. Don't do it. All we're doing is seeing, can you rewrite this in this form? That's all we're asking you to do. So work and answer, work and answer. Now, if you're wondering, hey, how little work can I show? You could actually, on this particular problem, do this. E raised to the ln x and e raised to the 5. Look at where the e is located. It is down and to the left. Same thing here. If you were looking to skip steps for this level of math, 16 raised to the and 16 raised to the. Now, how could you get this wrong? If you put your 16 in the front and it was the same size as this log, if this 16 ever goes below that 16, those are going to be wrong. I am absolutely going to be checking for how you are writing these answers because, or actually how you're writing your work and how you're writing your answers, because if you don't write it correctly, I will be taking off points. That being said, this test has one of the highest class averages of all of our tests. So just be careful. All right, to finish off, Chapter 9, Day 1, Question 4, we're going to be putting all of these skills together. So what is the opposite of log base x? It is x to the x raised to the log base x8 equals x raised to the 3/2. This cancels, and you get 8 equals x raised to the 3/2 power. Think back to the very first question. When I have an exponent that is a fraction, I'm going to raise it to the reciprocal power. This is 3 over 2. I'm going to raise it to the 2 over 3 on both sides. Remember, we have to do the same thing to both sides because it's algebra. These will cancel out and you get x equals, take this and break it into 3 equal pieces and pick 2 of those 3 pieces. That means the answer is 4. Yay! All right. This is a log base 16 again. Now, are all of these going to be log base 16? No, it's not. You'll have to pay attention. This number will change on pretty much every single problem. Because this is our lecture notes, I picked 16 partially because it's a really large number for this chapter. So we want 16 as the base with a log base 16 to the 1/2 power up here equals 16 raised to the x. All of this cancels and we get 1/2 equals 16 raised to the x power. There is 1 2 here, and 16 breaks up into 4 2s, but this is a reciprocal, it's a fraction, and so this x is going to be negative. If you remember, we count the side away from the x over the side closest to the x. Notice, last time I showed this to you, the x was on the left-hand side. Many people just say, oh, you just put the right side over the left side, or the left side over the right side. It is the side away from the x goes on the top. The side closest to the x goes on the bottom. I am trying to trick you. So this is going to be a 1 on the top and a 4 on the bottom, And because this is a reciprocal, it's going to be negative. Now be very careful. Some people are going to see this negative, and they're going to flip the 1/4 and make it into a 4. That is not correct. This is your answer, and you're done. So, what could you do to use less work? So, again, you could put the x's on the bottom. And I'm going to tell you that this question right here is one of the ones that most people lose points on, because they'll put an x here and they'll put an x here. Do you see how this 2 is below that x? I'm going to take off a half point for that. So make sure that it is an x raised to the 3/2 if you are going to use this method. That's why a lot of students rewrite the entire thing, because they don't want to lose that half point, because so many people get 100% on this. But can you do that? Just make sure that this 16 is a base, and this is up in the corner as an exponent. 16 is a base, and that is up in the corner as an exponent. If you put the 16 on this side, if you put the 16 in the front, if you put the 16 up too high, it's not going to work. If this 16 is ever lower than that 16, it doesn't work. Hey, look at this work that I want on both sides. You could actually probably get by without that one on this, but this one, I want to see this work. Because this will count as the work for this problem, and then the answer. This will count as the work for this problem, and then the answer. That's it for day 1.